Okay, welcome. So I'm going to give you an overview of the system that we're going to be using in this course. Um, it's called the HAS 200, and HAS stands for Highly Automated System. A highly automated system is something that, like in manufacturing, means that it's essentially a lights out manufacturing system, which means you can set up an order on a computer, press go, and it goes and just coordinates all the movements, everything that has to be done to produce those products. So this is how high volume manufacturing is done. And as I mentioned earlier in the introduction, the people in these areas are not involved in the manufacturing of the products. They're involved in maintaining and calibrating and testing the equipment and making sure it's running smoothly. So this system that's actually set up in the Advanced Technologies Lab at Quinsigamond Community College, room 111Q, is an actual high-tech manufacturing system with real industrial-grade parts. So it's just like the kind of thing you would see in a real industry. So one of the things we're going to be looking at throughout the course is this thing called the automation pyramid, and it's just a way of kind of categorizing the different sections of the system. So at the bottom layer, you have the things you can actually see that are doing the moving. They move around, grab parts, move them from here to there, put them on conveyors. And the sensors that are sensing either the position of something or whether the pressure in an area is, air pressure is high or low, or all kinds of things, temperature sensors. So those are all considered the hardware, basic hardware. The next level up, all those sensors and actuators have to be wired back to some kind of a controller. And the controller is the real brains of the operation. Now, this is what we're talking about is every station on the system, a local station, has a local controller. And all it does is it controls that one process. So typically this is done using a programmable logic controller, although you could set it up to be controlled by a PC or a microcontroller. PID control is one of the types of control techniques that's used to control motion. So that would be part of that layer as well. It's taking feedback from the hardware, from a sensor, and then delivering commands back out to the hardware. So there's a lot of communication. Most of the wiring is done between these two layers, the sensors and the actuators and the controller. Most of the course, most of what we're going to be doing in the course is going to be focused on these two layers because that's where most of the major problems, the maintenance, the alignments, sensors, electrical problems, they generally happen in these two layers. But the HAS 200 goes to higher layers. So once you get all these local stations doing their jobs, in order to tie them together or in order to even monitor them remotely, say across a network, you've got to tie them together on some kind of a network. So that's where SCADA comes in. SCADA is an acronym that stands for Supervision, Control, and Data Acquisition. And in order to have SCADA, you've got to have some kind of a network connection between the local controller and some kind of a centralized computer. So the simplest version of that would be like an Ethernet network. You've got Ethernet cables. Each PLC, for example, has an Ethernet connection and an IP address, and it ties back to a network switch, and a computer plugs into that switch. Now you are set up so you can create, well, not you, but some designer can create some software that will then drive that system from a remote location or monitor it. So so once you've got that set up with the local hardware, a SCADA network tying it together, the next level above that is the operational level where you're going to actually run the entire process. See, SCADA is really just to remotely actuate some various components or to monitor things, but it's not really at the level of actually running the process. So the MES layer, MES stands for Manufacturing Execution System. This is the software that allows you to put an order in, and then it coordinates all the hardware over the SCADA network to determine, um, what each piece of hardware is supposed to be doing, what each controller needs to do at any given time. It does some scheduling to make sure that, if there are three different machines that do the same thing, you can have the process run in parallel. So you can schedule certain machines and they get full of, busy, for example, you activate a third machine. So there's scheduling that goes involved, that goes into that. Then the very top layer, so let me stop here. The HAS 200 has all the way up through layer 4, all the way up through the MES layer. The next layer up is more like, it's considered enterprise resource planning, which is more like the business area. And there's a lot that goes on in there in terms of marketing and business and determining volumes and pricing and that whole thing, which is a big part of running the overall organization. HAS 200 doesn't go to that level, but that would be the next level up. It's more of an overall top level coordination. So we're going to be referring to these different layers as we go through the course. Again, most of please spending time down here on layers 1 and 2. So what we have with the HAS 200 is a fully functional automated manufacturing system. It has capability all the way up through manufacturing execution system, MES. It's a networked system, and it has the ability, when it's running in this fully automated mode, to track all the products. Each product is marked with a barcode, and that barcode at any moment is recorded at each station. You know how long it's been in the station, once it's done, how long it's spent there. So you can do all kinds of timing analysis. Those are kind of more high-level manufacturing functions, but the system is designed for all that capability. So we're going to be operating it. There's two different modes to operate the HAS 200. The first mode, standalone mode, means that each station is kind of independent. It's just for when you're doing troubleshooting. Most of what we're going to be doing is going to be in that standalone mode, making sure everything's working the way it's supposed to, the timing is correct, the alignments are there, everything's wired up. So the other mode is integrated mode, where the stations get switched over to a mode where they're listening to the server computer, the main server, for commands. So this is where you would set up an order and put the order in through the server, and then the stations would automatically start kicking into action and doing what they have to do to produce the products. There's a database that runs in the background, so every part that's produced is weighed and measured for volume. Those numbers go into the database along with the barcode and the time, exactly when it was measured and when it was manufactured. So you could go back through any process and research any individual product and find out exactly when it was made, how long it took, and all those kinds of things. Okay, so the products manufactured by the HAS 200 are basically these plastic boxes that are filled with either blue, yellow, or red pellets, or some combination of the three. These are the raw materials. We've got bins of these beads, and we have these empty boxes, and then there's a cap and a label that goes on the box at the end. The acronym, or the little name for these, are called Plas-Tacs. That's just a little name for them. Each one of the boxes has a barcode label on it, and that's how the products are tracked. And it has a colored label that indicates what color is supposed to go into the box. So there are, with these three colors, so one of the limitations is that it only dispenses in increments of 15 grams. So that means you can either have 15 grams, 30 grams, or 45. The boxes aren't big enough to hold 60 grams. If you try to put 60 in, it'll overflow. So there's your three options for any one color. So then if you do multiple colors, you can do any combination of colors as long as they don't exceed 45 grams. So you can see all the different possibilities of blue, red, yellow over here. Okay, there's a code for the products. It's a four character code. The first character is a letter indicating the color, either multicolor, blue, yellow, or red, then followed by three digits. The first digit is the amount of blue, the second digit is the amount of yellow, the third digit is the amount of red. So, and 1 stands for 15 grams, 2 for 30, and 3 for 45. So if it's we'll start at the bottom. If it's a red box with 30 grams, that would be 0, 0, 0 blue, 0 yellow, and 2, which should indicate 30 grams of blue. Now, if it's a multicolor, it would be, so let's say it's multicolor 2, 1, 0. That would be 30 grams of blue, 15 grams of yellow, and 0 grams of red. Okay,